Picnic, Natural Ecosystem Science for Production Agriculture. The inherent shelf life advantage of picnic produce, a scientific analysis from root zone to market. Picnic, Cultivating Sustainable Tomorrow Through Regenerative Agriculture. Abstract, this paper addresses a key farmer observation, that produce grown under picnic, natural ecosystem science for production agriculture exhibits a demonstrably longer shelf life than produce from ancient conventional industrial, ACI, systems. The analysis confirms that this advantage is fundamentally rooted in pre-harvest conditions that create a fruit with superior inherent quality, not just the absence of chemical residues. We detail how the picnic system, through a moderated root zone temperature, 13 degrees Celsius to 26 degrees Celsius, via thick organic mulch, creates a stable inner environment. This stability facilitates optimal microbial activity, stress-free plant physiology, and the development of fruit with robust structural integrity, balanced nutrient density, and high levels of natural antioxidant preservatives. Furthermore, we explore the implications for tropical fruits, optimal harvest timing, and the critical practice of field heat removal, providing a holistic view of how picnic principles ensure durability from harvest to market. 1.0 Introduction, From Farmer Observation to Scientific Principle. A perceptive observation from the field often precedes formal scientific inquiry. A practicing farmer recently posed a compelling hypothesis: the extended shelf life of fruits and vegetables under the picnic system is directly linked to the moderated root zone temperature achieved through its core practice of applying thick organic mulch. This paper formalizes this insight, providing the scientific rationale that validates the observation and positions picnic not merely as an alternative farming method, but as a holistic ecosystem-based science for producing inherently superior and durable food. 2.0 Core Picnic Principles, Engineering the Root Zone Environment. Picnic, Natural Ecosystem Science for Production Agriculture is predicated on replicating and enhancing natural forest floor conditions to create a perfectly functioning soil system. The principles critical to this discussion are: thick organic mulch acts as an insulating layer, protecting the soil from extreme temperature fluctuations. Moderated root zone temperature, maintained within an optimal biological range of 13 degrees Celsius to 26 degrees Celsius. Thriving microbial life, a diverse soil food web acts as a microbial kitchen, unlocking and blending nutrients from the soil organic matter as per plant demand. No tillage, preserves soil structure, pore spaces for aeration, and fungal networks. Balanced soil moisture, the mulch layer prevents evaporation and waterlogging, maintaining ideal humidity. It is the synergy of these principles, with temperature stability at the heart, that creates the foundation for quality. 3.0 The mechanism, how a stable root zone builds a better fruit. 3.1 The plant's inner environment. A stable root zone temperature is a master regulator of plant health. Root function, consistent temperature ensures uninterrupted activity of roots and their symbiotic mycorrhizal fungi. This allows for a steady, balanced uptake of water and the perfectly blended nutrient solution prepared by soil microbes. Plant metabolism, unlike in ACI systems where plants suffer metabolic shocks from soil temperature extremes, PQNK plants experience a steady, stress-free rate of photosynthesis and resource allocation. Energy is directed towards growth and defense, not survival. Hormonal balance, uninterrupted metabolic function allows for optimal synthesis and balance of growth, auxins, cytokinins, and defense, jasmonic acid, hormones, programming the plant for vitality and longevity. 3.2 Fruit development and structural integrity, picnic versus ACI. The quality of a fruit is determined at the cellular level during its development. Characteristic: picnic fruit, the resilient product; ACI fruit, the stressed product. Cellular structure: strong cell walls and membranes due to consistent calcium availability, aided by fungi. Weak, thin cell walls due to nutrient imbalances and rapid, forced growth from soluble fertilizers. Nutrition and dry matter: higher nutrition density and dry matter content, lower water activity. Balanced mineral profile. Water-loaded tissues from excess nitrogen, lower dry matter and diluted nutrient density. Defensive compounds, high levels of natural antioxidants, flavonoids, phenols, vitamins, and aroma compounds. These act as internal preservatives. Depleted levels of defensive compounds, as plant energy is diverted to abiotic stress response. Physical integrity, firm, resistant to bruising, and a less susceptible barrier to pathogen invasion, soft, prone to bruising, splitting, and rapid infection by pathogens. 4.0 The ripening process and response to post-harvest stress. Ripening is a form of senescence. The inherent quality of the fruit at harvest dictates the trajectory of this process. Picnic produce enters the ripening phase with a robust structure and a full complement of antioxidants. Its respiration rate is slower and more measured, leading to a gradual, predictable ripening process. Its high antioxidant content scavenges free radicals, delaying oxidative decay. When subjected to post-harvest temperature fluctuations, this resilient structure can withstand the stress far more effectively. ACI produce, already weakened, it has a high respiration rate, quickly burning through its limited sugars and acids, leading to rapid flavor loss and texture breakdown. It has minimal defense against oxidative stress and is highly vulnerable to post-harvest temperature swings, which accelerate its deterioration. 4.1 The climatic context, tropical versus temperate fruit ripening. The farmer's observation regarding the rapid over-ripening of tropical fruits like mangoes and bananas compared to the longer shelf life of temperate fruits like apples is astute and rooted in plant physiology and evolutionary biology. Evolutionary strategy, tropical fruits, evolved in climates without a cold winter. Their survival strategy is to be rapidly eaten by animals for seed dispersal. To achieve this, they developed high respiration rates, metabolically very active, quickly converting starches to sugars. High sensitivity to ethylene, produce and respond to large amounts of this ripening hormone, triggering a rapid, irreversible cascade. Softer cell walls, adapted for easy consumption. Evolutionary strategy, temperate fruits, evolved with distinct seasons. They need to persist longer for fall/winter dispersal, leading to lower respiration rates, a slower, more measured metabolism. Firmer cellular structure, thicker cell walls and waxy cuticles for protection. Different ethylene dynamics, a generally less dramatic production and response. This contrast underscores the paramount importance of the picnic system for tropical fruits. While their nature is to ripen quickly, the superior cellular integrity, higher dry matter, and antioxidant content bestowed by picnic practices provide them with the greatest possible resilience against their own rapid metabolic destiny, significantly extending their commercial shelf life. 4.2 Determining the optimal harvest stage. Harvesting at the correct stage of maturity is the first and most critical step in post-harvest management. Harvesting either too early or too late negates the inherent quality built by the picnic system. Physiological versus horticultural maturity. Physiological maturity is when the fruit can ripen off the plant. Horticultural maturity is the optimal stage for its intended use. For climacteric fruits, e.g., mango, banana, harvest must occur at physiological maturity but before horticultural maturity. Picnic harvest indicators. Reliance on visual cues alone is insufficient. PQNK advocates for a combination of scientifically backed, practical indicators. Total soluble solids, TSS/Brix, using a refractometer to ensure sugar levels meet a variety-specific minimum. Firmness, using a penetrometer to ensure the fruit has developed fully but is not yet soft. Visual cues, fullness of shoulders, skin color change, disappearance of bloom. Experience, the snap of the peduncle or a specific hollow sound when tapped. Harvesting at the right stage ensures the fruit has accumulated its maximum potential of dry matter, vitamins, and antioxidants, the very compounds that picnic enhances, and possesses the vitality to withstand the post-harvest chain. 5.0 The criticality of field heat removal. A fruit respires, generating heat. After harvest, it carries field heat, which can be 5 to 10 degrees Celsius above ambient temperature. This heat is a massive catalyst for deterioration. Why it's necessary: for every 10 degrees Celsius increase, the rate of deterioration, respiration, microbial growth, increases 2 to 3-fold. Leaving field heat is like allowing the fruit to cook itself from the inside out, rapidly destroying flavors, textures, and nutrients. The picnic method for field heat removal. Harvest during cooler hours, schedule operations for early morning or late evening. Prompt pre-cooling, move produce to shade immediately. Begin cooling within 1 hour of harvest. Forced air cooling, ideal, for larger operations, use fans to pull cold air through packages. Room cooling, good practice, for smaller holdings, use a well-ventilated, shaded cooling shed. Spread produce in a single layer. Hydro cooling, for suitable produce, immerse sturdy produce, e.g., carrots, some mango varieties, in cold water. The superior cellular structure of picnic produce allows it to withstand these cooling processes without damage, e.g., splitting. Removing field heat stops the clock on deterioration, allowing the fruit's innate picnic resilience to define its shelf life. 6.0 Implications for storage and marketability. The principle is clear: superior shelf life is built in the field, not created in the storage facility. The advantage of picnic produce is most profoundly evident in basic storage conditions. 6.1 The farm-level storage advantage: inherent quality trumps basic infrastructure. Picnic produce in basic storage: its foundational robustness, stronger cells, lower water activity, high antioxidants, allows it to resist spoilage longer. Its slower respiration means it generates less heat and deteriorates more slowly even at ambient temperatures, reducing losses and extending selling windows. ACI produce in basic storage: its vulnerabilities are exposed. High water content and rapid respiration lead to quick wilting, shriveling, and microbial rot. Without constant cooling, it deteriorates rapidly, leading to significant financial losses. 6.2 CA storage: maximizing an already superior product. Picnic produce is inherently CA ready. CA technology acts as a complement, further slowing its already slow metabolism to preserve its excellence for extended periods. ACI produce, CA storage is often a necessary corrective measure to mitigate inherent weaknesses and prevent rapid spoilage. It attempts to fix in storage what was broken in the field. Conclusion of Section 6. The picnic system provides a democratic advantage. It benefits the smallest farmer with a simple storage hut by drastically reducing losses and extends the value proposition to the largest exporter using state-of-the-art CA technology. The proof of picnic's superiority is on the farmer's shelf and the vendor's cart, where its produce remains fresh, vibrant, and saleable long after ACI produce has succumbed to decay. 7.0 Conclusion: The farmer's hypothesis is scientifically robust and correct. The extended shelf life of picnic produce is a direct outcome of its foundational practices. The thick organic mulch moderates root zone temperature, which facilitates a bloom of microbial life and stress-free plant physiology. This results in the development of fruit that is structurally and biochemically superior. Picnic, Natural Ecosystem Science for Production Agriculture, under the leadership of Mr. Asif Sharif, moves beyond simply replacing chemical inputs. It represents a paradigm shift towards managing the entire agro-ecosystem to produce food that is not only more nutritious and flavorful but also inherently durable, echoing the resilience found in natural ecosystems. About Picnic, Natural Ecosystem Science for Production Agriculture is a knowledge system developed and propagated by Mr. Asif Sharif. It is based on the principle of mimicking the natural forest ecosystem to create a self-sustaining, highly productive, and regenerative agricultural model. Picnic emphasizes the role of soil microbes as the chefs preparing perfect meals for plants, leading to the production of food with superior aroma, flavor, taste, and nutrition density. This advisory is based on proven picnic principles and field observations. Adapt timing and practices to your local conditions for optimal results.